Hello students, we will continue with topic 3.5, that is drift of electron and the origin of resistivity. So we started the chapter with a simple definition of electric current where we stated that the motion of the charge or the net amount of charge per unit time gives a steady current. But the current is not always steady inside the conductor because these electrons collide with the ions oscillating about its main position. We have also studied that the charge will come into motion in the presence of an electric field or when the potential difference is applied. In the absence of electric field, the current is zero. So we start with the same concept. Let us consider a situation where the electric field is zero or this conductor is not connected with a cell or battery. Now in this situation, this dot indicates the electrons which are in random motion. So we consider the random motion of the electron, and we have said that on an average the number of electron or charge passing through the cross section is equal to the number of charge crossing the same cross section in the opposite direction. So the net amount of charge comes out to be zero, and therefore the current is zero. Now these ions are in random motion. These free electrons are in random motion, and we have ions oscillating about its main position. So we have ions which are fixed. These are the electrons, random motion. So this is the situation in the absence of an electric field. That is the random motion of the electron. Now let us consider any one electron at any instant. There are number of electrons in 1 mole of substance. So if we say there are n number of electrons, all the electrons are in random motion. But to understand the concept, we will consider or we will observe the motion of any one electron or a two electron. We will talk in the terms of number, but you have to remember these numbers are very large. So again I am repeating that a conductor consists of free electrons which are in random motion, and ions are fixed about their geometrical point or a lattice point, and they oscillate about its main position due to the thermal energy available to them. The thermal energy available to them or a conductor is given by 3/2 kBT. So kV is a Boltzmann constant, T is a temperature in Kelvin. Now when this or any electron, say moving with a speed of 10 meters per second, collide with the ion, their velocity or their speed becomes zero momentary. Momentary matlab tends to zero. So it is not that they will come to rest, because charge inside the conductor can neither be created nor destroyed, and when we connect a battery, they never stop also there. So inside there is no situation where the electron will come to rest, because thermal energy is always available to them. So they are in random motion. But as they are moving in a random motion, they collide with the ion. Now suppose that the speed of any electron is 10 meters per second and it collides with the ion. So its energy will be transferred to the ion, and as a result the amplitude of oscillation of the ion will increase. And we will talk about this oscillation of ion later on. Now this electron, when it strikes with the ion, it is thrown in a random direction, and again it emerges or it starts its motion with the same speed. So whenever an electron collides with the ion, after collision they emerge or they move with the same speed but in the random direction. So if their initial direction is say x, they will collide with the ion, thrown away. Now they are moving in a z direction or y direction. Then their speed will be same as it was before the collision. They emerge with the same speed, but their direction is different. So their velocity is changed. So this is the situation of the electron in the conductor. Now let us consider, to understand this, let us consider a motion of an electron. So let us assume this electron, say electron number 1, in the absence of the field, is moving with the speed v1 along the x-axis, so its velocity is v1. Then there is another electron, this is on an average we say, but let us assume it consists of only 2 electrons. So there will be another electron 2 which will be moving with the same speed in the opposite direction. Now if I want to find out the average speed, it comes out to be 0, because it will be 10I minus 10I divided by 2. So I am taking the average of the velocities of electron. So there are n number of electrons. If there are 2 electrons, then if one is in x, then other will be in minus x. If one is in xy plane, the other will be opposite to it. If one is in y direction, there will be opposite to it in negative y direction. So overall, if I take the average of all the n electrons, its average comes out to be 0 in the absence of the field. So this is the first situation, because we have to see the drift of electron. Drift of electron means the electron will move in a particular direction in the presence of electric field, or when the electric force will act on it, and then while moving they will collide with the ion, which will be referred at microscopic level as the origin of resistivity. So it is clear that the average velocity, and therefore we say on an average the amount of charge crossing the cross section C is 0, because if 2 electrons move towards B, there will be 2 electrons moving towards A opposite in direction and with the same speed. So the resultant or average comes out to be 0. So instead of resultant, it should be the average of the velocity of all the electrons. So let us consider there are capital N electrons. There is capital N electrons. All the electrons are in random motion, and after collision they will emerge with the same speed. So if I take the average velocity of all the electrons, I can write 1 upon n summation Vi, that is the initial velocity, where I is running from 1 to n, then this average velocity of all the electrons comes out to be 0. So this is the first situation when there is no electric field present. So you have to remember, electron after collision will emerge with the same speed. Now the situation is, and suppose that if I consider any one electron, let us consider the motion of any one electron. So for this diagram, suppose this electron motion is from say point B to point A. Now this is the motion of an electron. So earlier it was moving in this direction, it collide, it is thrown in this direction, then again collision, thrown in this direction, like this. So in the absence of the electric field, the electron moving in the random direction has moved from B to point A. Now we will see when the battery is connected to this conductor and how the drift of electron will take place. So now same conducting substance. Now the electric field is established. This is the direction of electric field, high potential to low potential. This is the potential difference applied across the cross section A and B. Now as soon as the electric field is established, all the electrons, some were moving towards this side, say towards the cross section B, some were moving towards the cross section A. Now what will be the effect of this battery or the effect of this electric field? So this is plus, this is minus. So electric field is established from cross section A to cross section B. Now we know that the electron should move towards a high potential. So electron move from low potential to the high potential. Now all the electrons inside it have no choice, but they will be accelerated under the influence of electric field towards, say, left from point B to A or cross section B to A. So now this electron, there will be no electron which will be moving in this direction. Now what happens as soon as all the electron try to accelerate? Now clearly the force acting on each electron will be equal to, force is equal to E, that is Q into A, and the direction of the force acting on an electron. So we know that electron will move in this direction opposite to the electric field. So I substitute the minus sign. So in the terms of vector, I write the force acting on each electron will be minus EE. Now according to second law, mass into acceleration, that is equal to minus EE vector. So acceleration of an electron is equal to minus EE upon the mass of electron. So without the diagram, I can say in the absence of electric field, all the electrons were in random motion. But in the presence of electric field, electric force will act on it, or all the electrons are accelerated in a direction opposite to the electric field. So now there is an acceleration of an electron. First, we will try to understand the motion of any one electron. But you have to remember there are n electrons inside the conductor. So this n number of electrons we can easily find if we know the density and the volume, etc. That we will see how to find out the number of electrons. Now each electron is accelerated from B to A. Now I will consider only one electron. Now this electron has no option, but it has to move from cross section B to cross section A. So for me it is towards the left hand side, or if I say like this, it is moving to cross section B to cross section A. And its acceleration is minus EE upon ME. Now as soon as it start accelerating, means its speed is increasing. So its speed was say 10 meter per second. Direction was opposite. Now this electron has no option, it has to move towards A. Now it is accelerating. So its speed will be more than 10 meter per second. Remember, this is the average of all the electrons which comes out to be 0. It is not that the individual velocity of electron is 0. So if this electron have a velocity 10 meter per second from A to B, this electron will have a velocity minus 10 meter per second. So minus sign indicate B to A. So the average of both the velocity comes out to be 0. So it is this equation does not mean that each particle have a 0 velocity. Each particle is under the influence of a thermal energy, so they are moving in a random direction. Now this electron will start accelerating. Now if this electron start accelerating, so there are many electrons, all will start accelerating. So all need to move in a straight line. Their tendency is that they should move in a straight line. Like we started with, when we started our chapter, we said that 3 electrons entered all together from A. 3 charges were entering. So here electron is opposite to the direction of the positive charge or a conventional current. Then we said that this electron or this charge will not move all together throughout the journey. Now we will see why they will not move all together. So their tendency is to move in a straight line all together with a constant velocity, or this acceleration is constant. Now there are also ions which are oscillating about its main position. So it may be possible that, let us consider only one electron. This electron which is accelerated, find an ion on its path. So what will happen? This electron will collide with this ion, and because the ions are heavier as compared to electrons, this ion will be thrown away. So its acceleration, or the electron which has gained energy, or the force, that energy will be transferred. So it has started, its velocity has increased, so its kinetic energy has increased. Now when it collides with the ion, its kinetic energy is converted or is given to the ions. Ions are fixed at their mean position. So position, energy due to position is potential energy. So that kinetic energy is converted into the potential energy, and they start oscillating with the magnitude. Its magnitude will increase. That we are leaving the motion of ions. We will talk about this when we will study about the loss of energy. So this, all the electrons are accelerated under the influence of this speed, but some of this electron will collide with the ion, and suppose when it collide, we say it comes to the rest momentary, matlab their velocity tends to 0 and it is thrown away. Say after colliding this electron comes here. This electron has not faced any collision, so it may be at this position. This also we assume has not faced any collision, so it will be moving like this. So we are trying to concentrate on one electron. So this is its path. Now electron is here. So this electron is now left behind these 2 electrons because it faced an ion, and this collision is the origin of the resistivity. So this path, the path of this electron is obstructed by this ion. Now as soon as it comes here, again there is a repulsive force of this, or there is electric field. Again it will start accelerating. Now it may be possible that this electron faced an ion, because ions are oscillating about its mean position. So say this is second electron. Now when it collide, it may come to this point. So again it is coming backward. And by the time this ion will changes, because it is oscillating, this will come to this point, say. Now this electron is accelerating and now it is not facing any collision. So it comes here and now this electron number 2 will start its motion. So what will happen? In the absence of field also, the electrons were colliding with the ions. But they were thrown in a random direction. And they will not move against the field because there is no field. So they can move anywhere. All electrons are in the presence of the field they tends to move from cross section B to A. They have to move under the influence of electric field, which was not the condition in this situation. But they will also face the collision with the ions, and ions will throw them in a random direction, and then they again accelerate from B to A. In this situation, if any electron is thrown back from this position, it is not necessary that it will move from B to A. It may go anywhere due to thermal energy available to them. In this case, all the electrons have to move from B to A. So this should be the clear. They will face the collision, and the path is, see the path of this one electron. Now suppose we talk about one electron only. It is moving. Now it faces an ion here. So again it will be thrown back. So again it will start its motion. Again if it faces, it will go here. So but what will be the advantage? It is moving from cross section B to cross section A. So finally this electron will come out from the cross section A and the circuit will be completed and the current will start flowing. But they will not come out without any obstacle. These obstacles or collisions of an electron with the ions is referred as the origin of resistivity. So if anyone say what is resistance, so if I want to define resistance, it is the obstacle to the motion of a charge. The obstacle to the motion of the charge. But what is this obstacle? It is nothing but the collision of electrons with the ions oscillating about its mean position. So this electron was in the random motion in the absence of the field. This is its path. Again, if I consider this one electron, any one electron, it started its acceleration in the presence of the field, but it faced an ion and it was thrown away. So now again it is moving in the random direction. So this dotted line is in the presence of the field. But what will be the advantage? Instead of coming to a point A in a unit time, say, in the presence of field, it will come to A dash, means the distance or displacement will be more. तो जब फील्ड नहीं थी तो इलेक्ट्रॉन was in random motion and it comes up to point A. Then again it may move backward, forward, anywhere. In the presence of the field, again the motion is random. But after collision, this electron is accelerated against the field. And in the same time interval, if we can observe this electron, instead of coming to the point A earlier, it has reached up to point A dash. So what is the effective displacement? This is called effective displacement. Effective displacement means इलेक्ट्रिक फील्ड लगाने का कितना फायदा हुआ. तो earlier the position was from B to A, now the position is from B to A dash. So what will be the displacement? Final position minus initial B A dash minus B A. Now displacement is the shortest distance, so this is called effective displacement in the presence of the field. So this is the difference in the absence of the field, in the presence of the field. So in the presence of the field, first concept says all the electrons are accelerating. We will come to their velocities also. That is, now this is called drift of electron. This is called drift of electrons. Electrons are drifting from one cross section to the another, or from one end to another. So in the presence of field, all the electrons are accelerated by this value. While accelerating means their speed is increasing. Now as their speed increases, their kinetic energy. Then they collide with the ions which are oscillating about its mean position. Their velocity or say speed tends to zero. They are thrown in a random direction. Again they accelerate and move towards the cross section A only. And like this they keep on colliding, and they will continue their path or motion from one end to the another. And in a unit time interval, if I compare the distance or displacement, in the absence of field, this was in a random motion, solid line B to A. In the presence, again random motion, but it is accelerated, and so the distance covered is B to A dash. So effective displacement will be measured as, or the effective displacement is A dash, that is the shortest distance. So this will be called as effective displacement in MCQ. If we get any MCQ, then it should be the effective displacement. Now let us talk about their velocities. The average velocity of all the electrons was 0. Now let us come to their average velocity, whether it comes out to be 0 or it is not equal to 0. So it should not be equal to 0 because there is a force acting on it. It is an accelerated motion. So what will be the average velocity of all the electrons? Now let us consider only one electron. So let me consider this one electron. Now I am observing this electron which is somewhere here. It has to move from cross section B to cross section. I am observing this electron at time t. So t is a time when I started my observation. Suppose we are able to observe this motion. So that is a time t. Say, let me take this as an example that I started observing this electron at 1 p.m. Suppose this electron has its first collision before time t. हमने इस इलेक्ट्रॉन को कितने बजे देखना शुरू किया? 1 बजे देखा. Now its collision, first collision say, is before 1 p.m. यानी हमारे देखने से पहले कोई collision हुआ है, तो let us take that time as t1 or t dash. Let us take that time as 12:55 p.m. यानी हमारे देखने से 5 मिनट पहले इसका पहला collision हुआ था. So we started this observing this electron. हम इसको 1 बजे देख रहे हैं. इसका पहला collision हमारे देखने से पहले 12:55 पे हो गया है. Now we started observing it, and its second collision took place at 1:05 p.m. मतलब 5 मिनट के बाद. तो 5 मिनट पहले हमारे देखने से 5 मिनट पहले कॉल्यूशन हुआ जो हम देख नहीं पाए, और जब हमने कॉल्यूशन देखा तो 1:05 था. मतलब इस 10 मिनट में इलेक्ट्रॉन का कोई कॉल्यूशन नहीं हुआ. अगर उसका कॉल्यूशन नहीं हुआ है तो दैट इलेक्ट्रॉन इज एक्सेलरेटेड. दैट इलेक्ट्रॉन इज एक्सेलरेटेड. So this is the time interval where the electron is accelerated, and therefore for this particular electron I will say its relaxation time is 10 minutes. Relaxation, देखो relaxation किसी से टकराया नहीं. और जब इलेक्ट्रॉन रिलैक्सेशन मोड में है तो मीन्स इट इज एक्सेलरेटिंग. नाउ इफ इट इज एक्सेलरेटिंग, its velocity should be more than its initial velocity. So initial कितनी थी उसकी 10, वो भी डायरेक्शन तो रैंडम था. Now the direction is fixed. All the electron has to move from cross section B to A. So अगर if this is the first electron, I will take the final velocity, say V1 is equal to initial small v, this is capital V, V1, say this initial, plus 80, A की जगह I substitute this value, so it comes out to be minus EE upon NE. And what will be this time? This time should be equal to when it is accelerated. So that will be T2 minus T1, or I said it is delta T. This is for one electron only. So its final velocity will be this answer, that is initial minus something. Similarly, if I consider second electron, now second electron का observation किया तो it is not necessary that its relaxation time is 10 minutes. So some electron will have relaxation time more than 10 minutes. Some will have the relaxation time less than 10 minutes. So that the relaxation time of the electrons will be different. Their velocity initials were different. So their final velocity will be different. Now you have to consider all the electrons. Again I am saying we were observing the first electron only. So we started our observation at 1 p.m. and we assume that its first collision was at 12:55 p.m. and after our observation we saw again a collision at 1:05 p.m. It means the relaxation time or time for which electron is accelerated is 10 minutes. So this 10 minute is called the relaxation time. This 10 minute is called the relaxation time. And similarly, we talk about second electron, third electron, fourth electron. We have to find out the individual velocities. But you have to remember that all the electron will not have a same relaxation. For one electron it is 10 minutes, for other electron it will be 15 minutes, so for other electron it may be 1 minute. For some electron the relaxation time is not there. They keep on colliding continuously. So now you have to take the average, like we took the average of all the initial velocity. So I will take the average of all the final velocities of an electron. So this was one was written for first electron. So let us say the time interval is relaxation time for the first electron is delta T1. Now let us name them as T dash or T1. Now we have to take the average of all the electrons. You have to remember that the relaxation time will be different for different electrons. It is not necessary that relaxation time is same. So you have to remember this is a relaxation time of each particle or each electron. So if I keep V1 T1 or delta T1 say relaxation time, then V2 delta T2, that is the relaxation time of second electron, third electron, like this. So we take this as the time between two consecutive collisions for any electron. This is the time interval for any the time interval between two consecutive collisions. So if there are n number of electrons, let us say this is ith particle. So instead of 1, 2, 3, I put I, where I is running from 1 to n. So V1, V1, T1. If I say what is T1, it is a time elapsed after first collision. So this was the second collision, this was the first collision. So time elapsed after the first collision is 10 minutes. So we will call it relaxation time. Then another electron, so V2, initial V2 minus T2. If I say what is T2, not this T2, time elapsed after its last collision. So its last collision was at 12:55 and now the another collision is at this point. So it is a relaxation time. So for example, I have taken T1, T2. Here this is a relaxation time for each electron. It will be called time elapsed. It will be called time elapsed after last collision. After last collision. So its last collision was 12:55 and after this collision the another collision was this. So I will say the time elapsed is 10 minutes. So after 10 minutes it have a collision again. Now it is not necessary that this electron will have the relaxation time same throughout its journey. It may be possible that after this collision, this was its first collision, this is its second collision, so 10 minutes was the situation when the electron was accelerating, so its speed increased, and that is what we are finding. Now it may be possible that it will not collide anywhere. So at that time, this should be the time interval after its last collision. So suppose now there is no collision and you are observing this particle again at say 2.05 pm, 1 hour, after 1 hour. So 1 hour it has no collision. So now its final velocity will be different. So you put here 1 hour. So the situation is again random inside. The final velocity keeps on changing, or the relaxation time keeps on changing of all the particles. So I have to take an average. Now if there are n number of electrons, I will take the average of this. So this is Vi, its average. So average is simply summation 1 upon n. That also I can write Vi average minus EE upon ME. Now this will be Ti average. So if I consider only one electron and if it has first time the relaxation time to be 10 minutes and in second situation it has a relaxation time for 1 hour, then I take an average and substitute here. So I will get its final average velocity. See the situation. I am taking only one electron. In first situation, the relaxation time is 10 minutes. Assume there is only one electron. So in first part, the relaxation time is 10 minutes. Now if I ask you what is the velocity at that time, you substitute 10 minutes here. And initial is known to us. It will be non-zero. The average of all comes out to be. So you find out this. So this will be the velocity of a particle at 1.05 pm. Now suppose the second collision occur after 15 minutes instead of 10 minutes. Then you substitute 15 here. Find out its final velocity again. Now for an entire journey, what is the average? So I will take the average of this first particle. So first particle V1, initial whatever is the value, minus E upon M, first collision first relaxation time was 10 minutes. So I find this value. Then I take V2. V2 means the particle number 1 only, but now the second time its relaxation time is 20 minutes or 10 minutes. Because it is not necessary that it will collide after every 10 minutes. Sometime it will collide less than 10 minutes or more than 10 minutes. So in second time, its relaxation time was 20 minutes. So new velocity. Now the entire journey is over. It has come out from this cross section. There was only one electron. So I take the average of this. That will be V1 average. That will be V1 average. So this is how you have to calculate the final velocity and the relaxation time for each and every electron at different instant will be different. Now I take n electrons. So this I run from 1 to n, I run from 1 to n, Ti average run from 1 to n. Now this entire final velocity average is denoted by Vd, that is drift velocity. And this average, that is this value, it is 0. So 0 minus Ee upon Me, and this Ti average is referred as tau. That is the relaxation time. That is the relaxation time. So the drift velocity, now the electron is drifted from one end to another end, and Vd is equal to minus Ee upon Me tau. This is the expression for a drift velocity. So drift velocity is actually the average velocity with which an electron is accelerated from one end to another end in the presence of electric field. Drift velocity is an average velocity by which an electron is drifted from one end. Here drifted means they will not move straight, they will keep on colliding and they will come out from the other end. So it is an average velocity. And this tau is the relaxation time. Again, it is an average time. It is the average time interval between two consecutive collisions. So in the first part, let us assume only one electron. Remember this. So if I assume one electron, for the first time, its relaxation time was 10 minutes. So I find out the final velocity for 10 minutes. Then again the relaxation time is 20 minutes. That is time between the two consecutive collisions. So this particle has two cycles of two collision. So first collision was say 1255, other collision was 1.05. So for 10 minutes it have a acceleration. So I will find out drift velocity for 10 minutes only. Then after 1.05 again I started observing. So it will become initial for the second part. You have to remember this initial is in the absence of the field. That was say 10 meter per second. Now for the second part, this will become initial velocity. Again the particle is one only. So I say this is one part. So first collision, second collision. Now third collision occurred at say 1:30 p.m. So that is 25 minutes is a relaxation time. Only one electron we are concerned. Now the final of this will become initial for this. And now you keep this 25 here. Here it will be V1 dash say at 1:30 p.m. and what was 1.05, it will become initial. So if I talk about only one electron, I have to take this initial velocity. But if I am taking the average of all the n number of electrons, like if I stop this for one electron, say one for one electron, this situation is over. So I find the average of this. This average velocity is called as a drift velocity. and the average relaxation time will be referred as, the average time interval between two consecutive collision will be referred as the relaxation time. But we have to consider all the n electrons, so we take the average of this final velocity. And initial, for first particle it is 10, so there will be another particle minus 10. Then if this first particle has a relaxation time of 10 minutes, there will be another particle having the same relaxation time. Now their direction is same, so they will move together. But if there is third electron whose relaxation time is different, so its V will be different. So if it comes out to be less, it will be behind. If it comes out to be more, it will be ahead of that too. So we draw a situation like this, that all the electrons started accelerating at the same time when we connect a battery. But by the end, some electron will come out earlier, some will be entering this, some will be on the verge of coming out, and some will be left behind. So charge 3 started their motion at a time, they will be 3 only. So its drift velocity will be different, its drift velocity will be different, its drift velocity will be different. For all the entire case, we can take a average. Otherwise, individually drift velocity, drift, you take a average of all these things. So this is the average velocity by which an electron is accelerated from one end to another in the presence of an electric field. So drift velocity is defined as, the average velocity is defined as average velocity by which, drift velocity is defined as the average velocity by which an electron is accelerated in the presence of electric field, from one end of conductor to another end of conductor. So this is the definition of the drift velocity. So it is defined as the average velocity by which an electron is accelerated in the presence of electric field from one end of conductor to another end of conductor. And the relaxation time, which is denoted by a symbol tau, it is the average time interval between two consecutive collision of an electron, average time interval between two consecutive collision of an electron with ions. So it is an average time interval. So relaxation time is nothing but it is an average time interval with which average interval between two consecutive collision of an electrons with an ion. And you have to remember that this drift velocity is independent of the time, means this time interval. This time interval is the relaxation time, that is the microscopic time interval inside the conductor. This is the time interval inside the conductor, or it is a time between the two consecutive collision of electron. So it is not that when electron enter at 12 o'clock and it comes out at 1 o'clock say, so you cannot take tau as 1 hour. This is not a situation. We are discussing about the origin of resistivity. So at microscopic level, this is the situation. In the absence of the field, electron move randomly. Their average velocity comes out to be 0. In the presence of the field, all the electrons are accelerated from one end to another. But while accelerating they keep on colliding. With the ions, and this collision, the time interval between two consecutive collision is referred as relaxation time, and their velocity will keep on changing. It accelerates, then becomes zero, again accelerated, becomes zero. If I stop the journey, then I take the average of these two velocities, which is called as a drift velocity for that particular electron. But there are n electrons, so we consider the average of entire system. And this collision of electrons with the ion is being referred as origin of resistivity. So resistivity comes into picture when the electron collide with the ions. So this is drift of electron and the origin of resistivity. Have a nice day.